All right, so diving into conic sections a little deeper, let's start with circles. I want to explain for each type of conic curve the sort of geometric derivation, like the geometric definition, sort of where, like how you can think about these curves geometrically. So first of all, the circle, the idea of a circle is basically it's all of the points in the plane which are a fixed distance away from some central point. So like in this image here, I have this central point, which is labeled HK. That's our center. And we're going to be using the letters H and K to represent the coordinates of a central point for pretty much all of these conic section curves. Get used to that. And then the point XY over here is a point which is actually on the curve. And you can change, and that distance between HK and XY there is our radius. So over here on the left, you can see this parameter R. I can change here. So I'm changing the radius. And that's the distance between the center and a point on the curve. Now, depending on which direction you go out from the center, you'll get different points, but these are all exactly the same distance away. So going back to this page over here, GeoGebra, you can visualize this as a central point. Like take a string of a fixed length, that's your radius, and tack it to a central point, and then put a pencil at the other end of the string and drag that pencil around, and you can trace out a circle. This is a compass. If you remember taking geometry in high school or something, then you probably used a compass. This is a very simple compass. So this is the idea of a circle. If, though, instead of having one central point, if you connect your string to 2 points, if you connect your string to 2 points like this and have a string of a fixed length, and then you stick your pencil up in that string and let the pencil kind of slide back and forth along the string, but keeping that length fixed, if you trace that pencil like a compass all the way around those 2 points, then you get an ellipse. So that's the difference between a circle and ellipse. A circle has one central point. An ellipse has a center point, but you have these 2 points called foci, which is the plural of focus. So you have a focus on the left and a focus on the right. And those are the points where the string is attached, and you're kind of tracing around by sliding your pencil along that string of a fixed length. What that means is that the distance between the point on the curve and each focus, if you add those two distances together, it'll be equal to a constant. And depending on how far apart the foci are, like if I grab these focuses and move them far apart, I can, and also the length of the string, I can change the string's length to be longer or shorter. Those two things will change the shape of the ellipse that's formed. So that's the definition, that's the geometric idea of an ellipse. So moving along, if we take that notion of like 2 foci and then the distances back to those foci being added together equal to a constant, let's take that and change it a little bit. Now we have the 2 foci, f1, f2, and we have a point on the curve P. And if you look at the distances pf1 and pf2, if instead of adding them together, if you subtract them from one another, and set that equal to a constant, in this case, this image right here, the constant's 1.27, and then say, let's look at all of the points where that difference is equal to the constant, what you get then is a different shape. You get the hyperbola. So this is kind of why I mentioned that a hyperbola is kind of like an inside-out ellipse. It's because instead of saying that these distances added together equals a constant, it's saying that these distances subtracted from one another, absolute value, equals a constant. You get this ellipse, or sorry, this hyperbola. So that's where the hyperbola comes from. And then the last one is the parabola. The parabola also has to do with distances being, and a relationship between distances. But with a parabola, instead of having 2 foci, you have one focus, which would be this point here. This point here I'm grabbing as a focus. And then you have a line called a directrix. So this line down here is the directrix. And then what you do is you say, let's look at all of the points where the distance to the directrix measured at a right angle, in this case here it's 6.92, that distance is equal to the distance to the back to the focus, again 6.92. And if you make that your definition and say, look, as long as that rule is followed, that those two distances are equal, then that's going to be a point on my curve. The curve defined by that definition is a parabola. So what we're going to be doing is we're going to be looking at equations of these types of curves from a few different perspectives, one of them being these geometric definitions, and using those geometric definitions to like come up with an equation. The next few videos are going to be on paper with pencil as I go through and show you how the algebra works out. But we will be coming back to these demonstrations and looking at them a little bit later on as well. And I'll send you a link to all these web pages.